So about Lab 1, we're supposed to shoot a video of the constant motion of one object, analyze this motion using tracker, use GlowScript to construct a computational model, which is based on the concept we learned last week, Newton's second law, and finally compare the model to observation by plotting both the observed and predicted position versus time graph. The result shows that the two graphs resemble each other and therefore proves that when there is a zero net force on the system, the object will be doing constant motion. We can understand this by looking at the formula. When the F net is equal to 0, the right part of the equation is equal to 0, therefore there is no change in velocity as time goes, so the object is in constant velocity. In my video, I just randomly chose a basketball in the dorm and let my roommate help push the basketball, and I captured this motion by my phone. Let's play the video first. In this real-world case, I just assume the frictional force is negligible in order to get a zero net force. Then I uploaded this video into Tracker. This is the screenshot of the Tracker page. Basically, what I did was set the frame range. The start frame is 29 and the end frame is 69. Then I specified the length scale in the video according to the diameter of a standard basketball, which is 24.6 centimeters. And next, I set the coordinate system. I placed the original point of the axis to the center of the basketball, and I set the positive x direction towards the right as what we normally do. And then I marked the average position of the basketball in each frame, and we can see Tracker provides us with a position versus time graph. It's correct because in the video the ball goes towards the left, which is in the negative x direction. The graph shows as time goes, the position of the basketball goes down from negative 0.1, negative 0.2 to negative 0.5, which corresponds to the coordinate system I set. However, if I flip the axis and the positive x direction is towards the left, which is the direction the ball moves forward, then the position versus time graph will be like a linear line, which is 45 degrees above the x-axis. Also, the position versus time graph shows a linear graph, which proves that the basketball does a constant motion. We can see from the spreadsheet the specific position of the basketball in each frame, and this enables me to calculate the initial velocity of the basketball. So the initial position and the end position I got from the spreadsheet is listed in this page, and the time range is 1.333 seconds, and the initial velocity is calculated to be delta x divided by delta t, so the x component of the velocity is negative 0.506 meters per second. With all this data, I go to the GlowScript to build the computational model. And this is the screenshot of my code. Since I didn't need to change anything in the first part of the code, I just didn't put the complete code here. So what I did was to change the mass of the ball to 0.62 kilograms, and I set the initial velocity of the ball to the number I just calculated. I also changed the t to be smaller than 1.333 seconds, which is the time range, and I set 0 for the x, y, z components of F net. And finally, I changed the equation of calculating the velocity and the position of the ball based on Newton's second law. So after setting all these changes, I ran the program and got this data with the observed data from the tracker and the predicted data from the computational modeling. I made this graph. These two lines are pretty similar because they are both linear, which shows that the ball is doing constant motion. But there is a little diversion between these two lines, probably because of the frictional force, which cannot really be negligible. Well, the linear graph just clearly shows that the object is in constant velocity when the net force on the object is 0. So that's all for my Lab 1 report. Thanks for listening.